Hello and welcome. Today I'm going to show a quick demo of Confluent tiered storage with FlashBlade as the backend. First, I have the control center open in a 5 broker cluster with about 1 GB per second of streaming data being produced and a consumer group following along. You can see I have 5 brokers and I have tiered storage turned on. And this topic, I have 100 terabytes of data being retained in this single topic. You see the disks themselves have a low amount between 23 and 36 gigabytes of data, very small compared to the full 100 terabytes of data stored in this topic. I also have a Grafana dashboard showing me a view of the data coming in and out of Kafka. You see here the gigabyte per second, both produced and consumed. The throughput on the FlashBlade backend, which is where the tiered data is being written off to, and about 3 gigabytes a second total throughput to the local drives on the brokers. Now, the first thing I'm going to do is take advantage of a new feature in Confluent, self-balancing Kafka. And I'm going to add a new broker to my cluster. So you can see now I have 6 brokers in total. I've added a new broker. And what will happen is Confluent will automatically detect this new broker was added and trigger a rebalance operation to move partitions over onto that new broker so I can split the load amongst that new system. Now I see in my dashboard, rebalance traffic is started with all the nodes beginning to rebalance data onto that new broker. And now, after approximately a minute and a half, the rebalance is complete. What I've just done is I've rebalanced a 100 terabyte topic in a minute and a half. So it's that easy to add new brokers and scale the capacity, performance, and take advantage of that new broker. The next thing I'm going to do is demonstrate the flexibility of FlashBlade to hold more than just Kafka, but other parts of a data pipeline as well. To do that, I'm going to start filtering a subset of the logs, the messages that are coming in, into an Elasticsearch cluster that's hosted on the same FlashBlade. Once I've started that workload, I switch over to this new dashboard, which shows both the messages per second that Kafka is processing, about 20 million in this case, and the documents per second that Elasticsearch is indexing. And here I'm running an 8-node Elasticsearch cluster, again, on the same FlashBlade. And beginning of a new workload on the FlashBlade, which is NFS reads and writes, because the Elasticsearch cluster is hosted based on NFS, and the Kafka tiered storage is using S3. So now you see we're ingesting upwards of about 130,000 of those log lines per second. And now we have on the FlashBlade approximately 1 gigabyte a second of writes on S3, but also 250 megabytes a second of NFS reads and writes that are coming from the Elasticsearch ingesting workload. If I now switch to Kibana, I can see this file beat index being created, 36 shards, quite a few documents already in there. With Kibana open, I can now issue queries and start to look at some of the log data that was processed through Kafka and Elasticsearch. What's interesting about this workload is that when I look at the FlashBlade UI, I can see the mix of different patterns from Kafka tiered storage and Elasticsearch. If I look at just the S3 traffic, I see a pretty steady write-only workload as data is being tiered off from the brokers into the tiered storage, about 1 gigabyte per second. And if I switch to NFS, I see this rising NFS workload, which is Elasticsearch indexing documents and writing those to the NFS storage. The final test I want to show is how tiered storage with performant S3 as a backend can also make the data easily accessible for historical queries, like with, for example, KSQLDB or Spark workloads. So I'm going to now, in addition to the streaming workload, the Elasticsearch index, I'm going to introduce a historical query on this 100 terabyte topic. So now my streaming workload continues at 1 gigabyte per second. My Elasticsearch ingest at 150,000 documents per second continues. And I've introduced a historical query so that I can do analytics and make use of all that historical data kept on tiered storage, all while having the simplicity and flexibility of scaling out and rebalancing my cluster in a minute instead of hours and days, all making Kafka much easier, more powerful, and flexible in my environment. This has been a demo combination of Confluent tiered storage and FlashBlade. Thank you.